so interesting is that when you have a function working in Sudoku that lets you like see if a move is valid, you can then just build it out a tiny bit more to actually be like an AI. So if we have something that just checks to see if we can place a move in our Sudoku, then we could actually just do a little bit of tinkering to change it and make it a while loop that looks through and tries to actually solve the problem. So Sudoku is a really good like question that lets us model, hey, how can we actually build this thing? So I want to start by getting some of your all's input. Let's start with a function. I'll share my screen. We'll start with a function that will validate some guesses for us. So if you remember from last time, we said, okay, we need a function to see if a player's guess is valid. And the format that came in was an array of ints where, Sam, what was the format for each of these arrays? What information were they indicating?
The column, row, and the value.
Yep. So each subarray has 3 values. Array at the first index, they said was the row, is row for the guess. Array at the second index is the column for the guess. And then array at the third index is actually the value being guessed. AKA, can I add this to my Sudoku problem? Cool. What they actually did was they said, we're going to give you some indeterminate number of guesses. Is the guess valid? Cool. So we talked briefly about it, but one of the biggest questions is, how would you track this info? I suggested one, but I'd love to hear how you would track the guesses.
A dictionary?
All right, tell me about your dictionary.
Well, I'm gonna paste my solution into the chat.
But I want to hear about it.
I'm not really sure if I could explain it properly. It's the way I implemented it kind of confused me a little while I was doing it. But basically, I store the value as a key.
The value as a key.
And I have the other coordinates, like the row and a column. I have an array of tuples containing those.
Of tuples. So does your dictionary look like this? That?
Yeah.
Or sorry, you
well,
said an array of tuples.
Yeah,
Cool.
there you go.
This is value, then your array, I'm guessing, is row, comma, column, like that.
Yeah.
Cool. Okay. Then what did you do with that? How did you use this?
As I was iterating through the array of arrays, I checked if an entry for the third number in the array, which is the value in Sudoku, if there is an entry for it, then I check if the first 2 values are already in that array of tuples. Because in Sudoku, if a value, like let's say there are 2 3s, if they share a row or a column, it's invalid. So I check that against the array of tuples.
Okay. So you see if that array contains the row comma value as a tuple.
Yeah.
See
This is
if
what it
the
looks like.
dictionary value for that key in the array has the row and column from the guess. Array at 0, and array at 1. Cool. Cool. Let's take a look. Kevin gives us a dictionary. Validate with dict. Let's have a look-see. So you take in the Sudoku matrix. Sounds good. For A, and A is what again?
Array.
Cool. A is the guess. Right. If the dictionary has the value, so if the key is not nil, if you look through them, that works. Cool. Let me ask you, does this handle the rows, the columns, and the subgrids?
I'm not sure about the subgrids.
Okay.
But well, like the overall Sudoku structure. I'm not really sure about edge cases, but it worked on the sample ones that they provided and some that I made up.
Cool. So let's see. If the value is one of the keys in the dictionary, then for each of those tuples of row comma value, we have a wrong input. Why? Tell me what that if statement is again.
So if the current value has the same row or the same column of one of the previous entries in that dictionary, which also has the same value, that means that like it's shared, and that would be an invalid Sudoku problem. So wrong input.
Okay. So if for a given value, if the row matches or the column matches,
Yeah.
cool. That's great. That's a great way of working backwards. So if a row matches or the column matches, you have a wrong input. Otherwise, what do you do?
Otherwise, I have a tuple array variable, which I make equal to the value already in the dictionary because I already confirmed that it's not nil, so I could force unwrap it. And then I append the new, I guess, coordinates, the new row and column to that array, and then I assign it to the value to update the guesses in the array for the value.
Cool. So if not, do that. Sounds good to me. And then this default case is when.
The else is for when there's nothing in the dictionary. You just want to save the value with its row and column to start.
Cool. So what doesn't exist yet in that dictionary?
The key with the value.
Yep. The dictionary doesn't have a key for the guessed value. Cool. This looks great. What I'd be interested to see, and I gotta work up a test example. let's get that out. I want to see if this works for the smaller grids. So if you remember, let me share this. If you remember, they call it a subgrid, but Sudoku, you can't have any matches between rows, columns, or subgrids. So for example, I couldn't put a 5 right here in the first row, the third column, because in the second row, second column, there's a 5, and they're in the same subgrid. So let's try it out. Let's steal their inputs. I'm going to switch back to my Sudoku playground. And then let's make some assertions. Assert that returns okay, right? So if I call this function validate with dict array, that should return okay, right?
Yeah.
Cool. And then let's make that test set 1. Now I do have this. Cool. Let test set 1 be their first example that they put out. So looking through it, Liana, can you tell me, should the first test set of info come out okay or wrong input?
I'm sorry, were you asking me?
No, I'm asking Liana.
Sorry, I was on mute. Wrong input.
And why is that?
Well, they guess 5 twice, and they're both in the same, like the first number is the row, I think.
And so we see that guess twice in the same place. Cool. All right, what about Sam? What about our test set 2? Should that be okay or wrong input?
It looks okay.
Cool. I think so as well. I'm just going to change these because I'm a little retentive, but I'm just going to make this a bool.
I have a question.
Yeah.
On the actual like HackerRank thing, the sample input has a number before like the set of arrays.
Mm-hmm. Yeah, let's look at that in a sec. It's purely because they make you, or for other language types, and they don't bother to change this for Swift, but they make you validate the entire like standard in that they send. So all this stuff right here is so that they can set up an environment to evaluate the code in. Only here do they actually call validate. But this first number coming in, this 9, is just so they can set up. So Sudoku is going to be an array of arrays, and they're going to take in some input using readline, if you remember way back to unit 1. So for 1 in n, and n is that first number, where they actually go ahead and read someone's input. So they've already given you that manual input, and then they've taken that input to take 9, in this example, 1 to n. So take 9 read lines and then just go ahead and format that all for you for your array of arrays, this sudoku.
Okay, so we don't really have to worry about it.
Yeah, like on line 11, it says write your code here. They're doing all that work for you. In other languages, they wouldn't, but in Swift, like we generally work in an environment, whether it's making an iOS app or using a playground, where the input is evaluated for us.
Okay.
Yeah, I guess they just don't edit that here. It's also part of just reading this question is figuring that out, because it's a pain. Okay. So I changed those guys to be bools just because I feel like that's easy. All we want to know is this validated? Is this a valid input? We said the first, the empty array, should be a valid input. The second, where there's 5 in row 2 twice, should not be valid. And the third, test set 2, yeah, let's just do this. Is test set 2. So we're talking about things in order. Amazing. Cool. So it should be okay with empty input. It should be not okay where the rows match. And then this test set 3, Kevin, why does this work?
Test set 3.
Yeah.
Where is that?
Oh, sorry. What am I sharing? I hate this.
The other screen.
There
Oh, there you go. Test set 3 works because none of the threes share a row or column.
Cool. Exactly. None of the 3 share a row or column. Let's add a test set 4. And this is going to be one where we check out the subgrids. So we'll get rid of some of these actually, because we won't even need them. Let's look at 3-1 in terms of what we see here. 3-1 is row 3, so 3 down, and then the first column, which is right here. What's another guess I could put that's in that same subgrid, but not the same row or column that should invalidate it?
2-1. Oh, sorry.
No, it's okay.
2-1's good. Liana, what were you going to say?
3-2.
Cool. So let's go with 3. Let's look at those first, actually. So 3-2-1 is going to be right here. So if we're in the bottom left of this subgrid, 2-1 is right here. And if we're at 3-2, 3-2 is right here. So we will actually get we will get blocked for the row and for the column here. But if we pick something like 1-2, where neither the row or the column match, it's still invalid because the subgrid is not. The subgrid is the same as the previous guess. So if we had 1, 2, this should be invalid. And there's going to have to be a specific way that we construct for the subgrids that's going to lead me to why we should maybe use a different data structure. So Kevin, this is not to pick on you. This is a great start. And let's just check it out. Cool. So let's see what we got here. We've got this guy right here. Interesting. a given value. Aha, okay. I left something in there. Cool. That was not a good test case because even without what I was trying to test, we would get a false here when the rows match, and we would get a false here when the columns match. So I'm going to make sure this is tailored specifically to what we want to test. Make this 5, 4, 3, 1, 1, 2. Let's run this bad boy. So again, these first two guesses should be in the same subgrid. This third guess should be in a completely different one, but we should get back false. Okay, and that's where we're going to get the error assertion. So the subgrids are like I'm going to call them the fun part of this problem. I think it's fun. That's where it might be helpful to use a slightly different data structure. Kevin, there's definitely math you could do in here to figure out if you're in a subgrid, but having to look for these nested tuples might be a little tough. Does that make sense?
I definitely did not think this is the way to go about it.
Okay. I mean, you know, another approach, which is like, you can figure this out with a dictionary. I'd say a to do or to think on how to, how would you account for subgrids? And what I've seen people do, and by this I mean people you all know who I went over with this last week, is they made 3 different dictionaries for row, for column, row dict, column dict, and subgrid dict. And these were, just like you say, they were int, and then they were slightly different. They were set of int. Key being the guessed value again, and value being a set of the row or column or subgrid they were found in. Let's all snoop together. What's her name? Angela. There we go. So for example, Angela had an array. These could have been sets as well because there's a contains here. But to figure out whether the thing belonged in a row or a column or a subgrid, she checked, hey, does the dictionary that holds all of my found rows contain the value I'm looking for here? So does the dictionary have this row? Does a separate dictionary for the columns have this guess? And for the box, she just set it up this way. Just made a bunch of switch cases. Does anyone see a pattern with these switch cases? What she calls a box is what I'm calling a subgrid.
What's the question again?
So she's got this big long like switch case with nested switch cases, and it's to figure out what box, so what subgrid someone's guess is in. Do you see a pattern for figuring that out?
You switch on the row and then the column to get the subgrid. And you go by 3.
Exactly. So for each we go by 3, which like visually makes sense, right? This is a 3 by 3 box. This is a 3 by 3 box, 3 by 3 all the way through. So the subgrids, based on what the row and the column are, we can switch those to figure them out. If that's the case, then chances are we can probably use indexes on an array to actually have a position for these things and look them up. So that's why actually my preference for this question is using an array. Does anyone have any ideas about how we could model this with an array?
What was it like? Explain what was it like for your brain to do this?
What was it like for your brain to do this?
Oh, sorry, guys.
No, it's okay.
I keep getting
I
on
think I love that question.
mute.
So let's look at Sudoku again. How many items are there here?
To find what is an item, is it just a yellow box or?
How many yellow boxes are there?
Mm,
Yeah, the risk of making a mistake is
81.
Yep. So there are 81 potential locations for a guess. Okay, cool. Of those 81, how many guesses can go in a row? And by guess, that could also mean like valid filled in guesses.
I guess I'm a little confused because you're saying valid guesses. How many valid guesses can go in a row?
Yeah, like if our validator doesn't work, we could guess a million guesses in one row, right? But how
Yeah.
many things can actually be filled in?
9.
Yep. And then how many things can actually be filled in any one column?
9.
Cool. Is that how you got 81? It's not a trick question. If I said there are 9 rows and 9 columns, how do you think we could construct that with an array? How should we construct our array?
Isn't it an array of arrays?
Yeah. We could have an array of arrays. And how many subarrays should there be?
And you'll notice as they change each letter, they're not erasing any part of the letter. They're just adding to it.
9.
Yep. And then Sam, how many elements will be in each subarray?
9.
Awesome. Love it. Okay. Does anyone know how to make this? Var, and I'm going to call it the grid.
No, this was a video. This was a video. I
Can you
found
just
on
do
my-
array, repeat it, like repeating or something like that?
I can do array repeating or something like that.
So here is.
So this
mine.
underscore is what's going to be in the array.
Does anyone
Let's start with the count. How many things are going to be
want
in the outer array?
9.
Perfect.
to-
All right.
you wanna call
Now,
out-
Kevin, what is the repeating element? What are there 9 of in my whole grid?
Subgrids.
So we will have 9 of those. That's a really good point. But in constructing this, in order to make it 9 by 9, what do I want 9 of? I know it's annoying.
9 arrays or 9 elements.
So we want 9 arrays with 9 elements each. How can I make that subarray in this repeating function?
Probably do this in a for loop.
We could, but this thing is going to spit out right now. Let's say underscore is a value. It's going to spit out, I don't know how many that is. 6, 7, 8, 9. Okay, I want to fill in each of those underscores. What can I create to fill those in?
I feel like I'm overthinking this.
I think you are too. What do you want to put in each row of our grid?
Values.
Yep, and each row is going to have how many values?
9.
So what can you create that holds 9 values?
And a variable.
Yeah,
Or
we could do it without even doing that.
a range.
We could
can
also
do
do
that.
range. That's a good idea. I think the easiest thing to do though would be to just make another repeating array.
Oh wow.
So a repeating array of 9 things, and I'm just going to say by default, an empty space holds the value 0. This will be important when we create our solver. I probably just need model. I don't think we'll get all to it today. But here's our grid. It just is 9 rows by 9 columns. I think I have this somewhere else. Yep. Cool. Here's what our grid looks like. Matrix. Looks pretty familiar, right? All right, so we've got our grid. And here's the thing. All we want to do is loop through, look at our rows and our columns, see if those things are in the row and the column specified, and find our subgrid. And the reason I like Sudoku is because the one thing that helps us here is that our grid is a fixed size, which means that when we look through, we don't have to check some dynamic number. Instead, to look at each row, what row numbers do I have to look through?
For you guys to make this do. So right now, what I want everyone to do. You have your
Are you asking us like what for subscripting what we have to look through?
Yeah, say I wanted to find each row, looping through, I don't know, maybe a range. What do I have to look through? How many rows are there?
There are 9 rows going 0 through 8. So you would subscript it grid 0 and then subscript 0 through 8 after that.
Yep, you could do that. And what's
the row is the first element in every array.
Yep. So the row is the actual element we're grabbing. So Liana, like you say, and actually it's another benefit of the like static nature of this. To grab a row, we're looking at rows 1 through 9, which in computers is indexes 0 through 8, right? And to subscript for a row, we just do grid at 0. And that 0 through 8 is the same thing as just grid at 0, right? Because the row is always the whole thing the whole time. Amazing. What about to look at a column? How many columns are there? So there are 1 through 9. And here is the very special and simple thing about our sudoku matrix here, is that at a given time, we can look just for the row and we can look just for the column. And because this is an array of arrays, we'll want to look to subscript for a row. We'll look at grid some number. And then the second subscript, so in the subarray, for the column from our guess. In the same way, what we're looking for when we look for the row is the row from the guess. So this is where we're actually going to process the input. How do we feel about that?
In line 54, it's supposed to be the subscript for a column, right? Or is it also a row?
Subscript for a column. The column from right here?
Yeah.
Oh, subscript for a column. Thank you. Yep.
Okay.
Perfect. Thank you. So we can't quite, I know I got really excited about this kind of setup last time. We can't just say like, give me any sum elements, but what we can do to simulate this is we can just have a for loop that looks through 0 through 8. So because of this fixed size, to get to any row and match it against the guessed row, and to get to any column and match it against the guessed column, we can just iterate through a constant, or let's call it a static range, 0 dot 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 8. How is this even simpler? So I'm going to write out my little solution for this. First, what we have to do is we have to iterate through the Sudoku matrix. So for guess in Sudoku matrix, and again, guess at 0 is the row, guess at 1 is the column, and guess at 2 is the actual value being guessed for that row column space. Okay, so for each guess, I can do something this simple. For 0 dot 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 8, if, let's talk about the row. If grid at the row, how do I get the row? Let's talk about what a row is in each guess. Row is 1 through 9. But for indices, what do we need row to be? To match the indices of this array, row must be
0 to 8.
Yep. And so if I wanted to store, let's let row equal something related to guess. How do I get the correct value?
Guess 1 minus 1.
Yep. Well, so which subscript is going to be the row?
Oh, guess 0. Wait,
That looks good to me. And then how am I going to get the column? Let's just do that now.
guess 1 minus 1.
Thank you. So we're just making sure that even though someone's guessing with like the human readable rows of 1 to 9 to match our grid, we're going to decrement them by 1. And then to look through the rows, well, if I look through grid at row for each I, so if I look at, let's say my guess is in the second row, I want to look at each of these. And I want to say, if that is equal to the value, let's return false. In the same way, if grid at I column is double equal to the value, let's return false as well. What's my error so far? Where do you see like a big red indicator?
You need to define value.
Yep. Kevin, what's my value?
I'm not exactly sure right now.
So value is just the thing being guessed. How do we get that out of the guess?
Guess row and column.
So we just get it from this guess that we are getting from iterating through the Sudoku matrix.
Would it be like guess subscripted by the row and the column or not?
It's definitely from guess, but I think you're making it harder for yourself than it needs to be. Just remember what the format of guess is.
Oh. It's an array of ints. So
It's an array
the
of
last
ints.
one, guess that last.
Cool. And that's going to give us an optional back. So just because we know the size, I'm just going to say guess at the index 2. But yes, the last, if we wanted to force them up, that is good. But row, column, value, guess all come from our guess. And then here, let's talk about what's going on. So for each row, so if I said the second row, I want you to look through indexes 0 through 8 in that array. So if I have my row 1, it's going to give me the index. Let me make this bigger. No, come back. Cool. So if my row is 1, I'm going to ask it to iterate through and look at 0 through 8. So this space, this space, this space, this space, this space, this space, that, and so on. So for any row, it's going to take that value, it's going to index it, and it's going to look across. Right? That's just iterating through an array, basically. This I goes up, and we know because it's a fixed size every time, that it'll go from the beginning, index 0 of that array, to index 8 of that array. So we subscript, and then we subscript again. This column business is kind of just the same thing. It's a little trickier to think about because it's not looking through one array. It's looking through all 9 arrays. So array 0, 1, 2, 3, 4, 5, 6, 7, 8 at the same index. So right here and down, this index 2 is the third column. So by looking at each array at the third index in that array, I'm looking at the columns. That's all this little swap right here is doing. So I'm iterating through each array in this one to get the columns, but only at one index in each of those arrays. So this looks at 9 locations. This looks at 9 locations.
Makes sense.
Cool. Everybody together so far? Go ahead, Sam.
Okay, gotcha.
Now, you wouldn't be able to get the subgrids using this range, right?
That's correct.
You'd have to use Angela's implementation.
We could use Angela's implementation. Let's make this note a little more general. Row and column are both 9 long, so we can iterate through. And Angela's implementation, I dig it. I think it's nice, but there's a way for it to be much less verbose. And that's where I want to talk about what we see here. So Angela has like picked out the pattern here, and she said, okay, if the row is rows 1 through 3, then the subarrays could be either the columns 1 through 3 of those rows 1 through 3, or 4 through 6 of those rows 1 through 3, or the default, which she means to be 7 through 9 of those rows 1 through 3. So rows 1 through 3, these are the top 3 rows. You get one subarray by looking at these 3, one subgrid, sorry about that, by looking at these 3, another subgrid by looking at those 3, and another subgrid by looking at these 3. So for each 3 rows, there are 3 subgrids. For each 3 columns, there are also 3 subgrids. It works, going up and down in the same way. Columns 1 through 3, there's this subgrid, there's this subgrid, and there's this subgrid. That's great. So there is a pattern there, which is that a subgrid is each 3 by 3 grid. And if we know the row and the column, we can find the subgrid using, and I hate to say it, but using math.
I knew it.
I'm sorry. What are the row numbers of the center subgrid? So row numbers.
4, 5, and 6.
Yep. And what are the columns of the center subgrid?
Same, 4, 5, 6.
Yep. So rows of center subgrid 4, 5, 6 columns of center subgrid 4, 5, and 6. And here's the thing. Working off our rows here, the indices for those, indices, I can never decide which I like. The indices are 3, 4, and 5. The indices are 3, 4, and 5. Here's where computer math helps. Regular sucks. In order for us to figure out the grid we want to look in, if we can find a starting point in each grid, so if we can say for each subgrid, start here, and you can iterate through the 3 rows and 3 columns. If we know where to start, we can set up iteration nearly as simple as what we have here. I want you guys to take 5 minutes. I'm going to stop my share. In terms of math, what were you all thinking could help you here?
One second.
What's maybe a better question is what's peculiar about computer math, especially when you have integers?
That's a big question.
I know. What about if we're only dealing with the numbers 0 through 8?
Computer math.
Are you referring to like bit manipulation?
No, sorry. Much more general, nothing like that, we'd have to divert on.
The only thing that comes to mind is, I guess, they round down.
Yeah, that's huge. When do they round down? When do they round it down?
Whenever it's a decimal. Or it should be a double. They round down to an end, no matter what the decimal value is.
Yep. So they round down in division when there is any remainder. How might that help? I'm going to share my own screen again. This is important. Let's go back and look at the Sudoku board. Say I am at, let's do it in terms of indices. So call these rows 0 through 8 and call these columns 0 through 8. Say I am at the index 5, 5. Where am I? Which subgrid am I in?
The center one.
Yep, I'm in the center one. And Liana, if I'm at 5, 5, in that center grid, which location am I at?
The center of the center.
So we're talking not row numbers, but rather indices.
Oh, indices. Okay. So the bottom right.
Mm-hmm. And I guess here is the huge question for modeling this, which is, how can I know which subgrid I'm in from there? What would be a good point of reference?
Okay. This is like just a guess.
Yeah, I guess that's good.
So don't ask me like how I came to this answer, but can you divide it by 2? or dividing it by some sort of number.
Yeah, we definitely want to divide it by something. And here's what I'm going to recommend. So remember, this whole thing is an array. What is the very first element in the array? What are the rows and columns of it if we're using array indices?
Can you ask that question again? Sorry.
Yep. So this is to anyone who wants to answer. What's the very first element in our array of arrays? What are the indices of it?
Zero, zero.
Yep. And say we if we look at these subgrids, we read through it and I go across the rows before I go down the columns, but it doesn't really matter. What is the last thing in that subgrid? What are the indices of it?
2.
2 and
Oh, 2, 2.
yep. So in our first subgrid, it goes from, let's use these as coordinates for now, 0, 0 to 2, 2. Okay, in our second subgrid, let's say we're going across in terms of rows, it goes from second subgrid, goes from row 0, column 3 to row 2, column 5. And our third subgrid, the top right corner, goes from 0, 6. And then what are the ending indices there, Sam?
Two, 8.
Yep. This goes from 0, 6 to 2, 8. And there's a pattern here. For each subgrid, to get to the next subgrid, you go up in increments of 3, whether it's in the rows or the columns or both. And so if for any row column, we can find the starting point of that subgrid, we can iterate through a short range. So if I'm in the first subgrid, if I start at 0, 0, I'll look at 0, 0, 0, 1, 0, 2, then 1, 0, 1, 1, 1, 2, and then 2, 0, 2, 1, 2, 2, and I've looked through the entire subgrid. Let's make that work. So for I in 0, 2, for j, this is usually how you see this set up, 0, 2, if the grid at I, j is the value, return false. That would work for the first subgrid. And this pattern, so this is for the first subgrid. This pattern though, pattern works for any subgrid so long as we can find the top left element of that subgrid. So if we find the top left, if we find the indices of the top left of that subgrid, we can just iterate through 2 spaces to the right and 2 spaces down to look through that entire subgrid. So this one here would be the same rows, 0, 1, and 2, but then the columns would be 3 through 5. So Liana, you suggested divided by 2. I think there's going to be division. What do you think we should divide by, though?
3.
Yep, I agree. So for any position, if we divide the row and column each by 3, well, it'll tell us, am I in this one, or this one? It'll help us find the starting point by then multiplying by 3. Because if I'm at 5, 5, and divide 5 and 5 both by 3, I get 1, because we drop the remainder. And then if I multiply each of those by 3, I get 3, 3, which is the top left. It's the starting point. So these subgrids, if we're using the indices, and that's why I suggested it, they're bounded by their division to the next whole number. It's a weird way of putting it, but basically in any subgrid, if you divide the row or the column by 3 and then multiply it back, it's going to shoot you to the top left corner. So let's say, for example, I'm in subgrid 6. Let's call this subgrid 6. The index of the top left is 3, 6. And if I'm at 4, 7, if I'm in the middle of this subgrid 4, 7, 4 divided by 3 is 1 times 3 is equal to 3. And 7 divided by 3 is equal to 2 times 3 is equal to 6. So what we're doing is we're counting on the integer math to give us an imprecise answer, or what we as humans would think is imprecise. We're counting on it to do the math in the way that computers do math, rather than the way that we do math, so that we can find the top left of that grid. And then all we have to do is set up 2 ranges that start at whatever division we got to this number and whatever division we got from this number, and then just 2 greater than that. So let's just calculate those numbers, and that'll make it easier for us. Let's let the row, the subgrid row start index equal, how do I get that out of the values I have here?
What are you looking for again?
So instead of having 0 like I do here and 0 like I do here, I want to find what number is the row of the top left of the subgrid that I'm in. Well, what value do we have for a row?
Would it be row divided by n times 3?
Yep. So the row divided by 3 times 3. Because this goes in order of operations, it does the division first, and then it does the multiplication. So we lose the remainder right here. Similarly, Sam, how would we do the column?
Column divided by 3 times 3.
Yep. So we divide it first. And so if we're at column 7, then this division gets us 2. Then we multiply it times 3, and we get 6. And 6 is the column of the starting element of that subgrid. Now here's all we do. For I in subgrid row start index, dot, dot, dot. How can I get 2 more than that?
Subgrid row start index plus 2.
Yep. For that, and then let's set up our column, subgrid column start index, dot, 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 subgrid column start index plus 2. If the grid at any of the rows combined with columns is equal to the value, false. So here we're looking by a 3 by 3 grid, starting at the whatever coordinate is subgrid row start index, comma, subgrid column start index. And that's how we look in the grid. So we're looking in the entire grid. It's going to start the top left, it's going to move across, then it's going to go to the next row, it's going to move across, then it's going to go to the next row and move across. And this is just probably my favorite part of, because Sudoku is a fixed size. That's why it's one of my favorite problems, is you can actually just do the math to make it work without worrying about the size of the game board you're working on. So if we break this down, I'm going to do what I did with this morning stuff. I'm going to turn this into just a function called validate guesses. If we break this down, cool. Start with a grid. We just have a game board. That's this guy. It's 9 by 9. And then do we have to do anything to that grid, or can we just get started?
You can just get started.
Sweet. So for guess in Sudoku matrix, row is which?
Guess 0.
Yep. And what do we do to that just to make it fit in our array of arrays that we're using?
-1.
Mm-hmm. And column is very similar. It's the second part of the guess, so the second element in the array. And then our value, the thing being guessed, is just guess at the second index. Sweet. Then we said, let's take advantage of the fixed size of our matrix. So if we look through here, all right, if we look through the subgrids, we can just calculate that based on the size of the rows and the columns. What else do we have to do here? We've done a bunch of checks. What happens if those checks don't come up false?
Return true.
So we're gonna get a janky thing right here because I still haven't done something to my grid.
You have to add the value to your grid.
Yep. When and only when should I add the value to my grid?
After it's checked that it's not there. So like outside the guess loop.
Okay. I would say let's do it at the end of the guess loop. So we can do it.
Okay.
Basically, we'll validate the row, we'll validate the column, we'll validate the subgrid. And if none of those turn up false, because those immediately return our function false, we'll just make the assumption, hey, grid at row column equal to value. So if the validations didn't fail, then we can add it. And then similarly, when is the only time we can return true?
Outside of the loops.
Yep. We can only return true. I mean, it's a weird way of talking about it, but we only return true if we didn't return false. So outside of the loop, if we made it through without ever having an invalid guess, that means that every guess was valid. Do we want to try this guy out? All right, I hope it works. I don't know. Kevin, I'm gonna comment yours out. Cool. I'm just gonna print something here to make sure that we reach there. Great. All right, so it looks like my validations work. Let's take a look up at that function. Think about your playground. Two of these return false, two of them return true. If you look on the side, does that reflect what our function found?
What was the question?
So the 4 tests that I had, 2 of them had valid moves and 2 of them returned false because they had invalid moves. If you look along the side of like what happens when I actually run the function, does that bear out with the executed lines that you see in like that side console?
Yeah,
Why is that?
it returned true 2 times.
Mhm. And can you describe the two times that it failed? How did it fail in those 2 times?
Once where the value was already in the same row, and another time where it was in the same subgrid.
Cool. Sounds great.